Yeah, it's good. Mm. Oh, air condition.
Mm.
Do you think
Aircon.
do you feel it's too hot?
I just like fresh air.
Ah,
It's nice to have some ventilation.
ah,
How are you?
it's not bad recently. Yeah.
Yeah.
One thing I want to discuss today is after I conducted this experiment, do I need to start to think about next project?
Yep.
So currently, what I think that I want, last year
Mm-hmm.
I can deploy my algorithm on real robots. So do you think it's a little difficult for my direction?
Yeah. What would be the research question?
So currently, so what I think if I want to deploy on a robot,
Mm-hmm.
what I need to do is I what I ne- so the how to say the direction I can choose is not only object detection but a specific area for object detection. So like catch something or focus on a specific thing like indoor thing or outdoor thing. Just
But when you say you want to deploy it on a robot,
yeah.
what do you mean?
So for example, if I design an object detection algorithm, I hope the robot can use this algorithm to catch something.
To actually like use a robot arm or something
Yeah,
to
yeah, yeah.
um I guess it's very different because maybe you would use an object detector to say where the object is,
Yeah,
but how you go from knowing where something is to generating robot commands
yeah,
to pick it up
yes.
is a totally different field that some people spend their whole PhD on just a little part of it.
Ah,
So I don't think it's realistic at all. No.
ah,
It's really hard to know how to take a gripper, even a simple gripper, and where do I grab this? How do I move my joints to get there? How do I not hit anything else at the same time?
yeah.
Once I've put my gripper, how do I pick it up without dropping it?
Ah,
Like that's a research field in itself,
so
let alone the fact
it's a
that you
little
haven't
different.
even done any work on object detection yet. All of the
Yeah,
stuff is just with classifiers.
yeah, yeah, yeah.
So
So,
it's yeah, it just wouldn't be possible. No.
ah,
Maybe what you could do is try and get the stuff that you have developed into an object detection model.
so just focus on object detection, but not on a real robot. Like,
If you wanted to, you could collect some data that that a lot of like the data sets are very curated.
uh,
It's like it doesn't look anything what a robot feed would look like.
yeah,
It's like photos and stuff from the internet.
uh,
If you wanted to, you could collect a data set that looks like a robot moving around an environment
yeah,
and test on that, but you would have to then label it, which is a big job. Or
uh,
maybe there's data sets that look less like internet data sets. I think there are actually, now I think about it, some that are more like robot-y object detection data sets.
uh, uh, so, uh, so how about that? So, uh, at first, what we discussed is the last project should be, mm, la, uh, uh, so if if the target is not in the query list, how I address it? Do you think currently I still can do that? I think this is interesting, but
What to do if the target is not in the query list? Do you have your okay, so do you mean more like if you know the target's not in the query list, what do you do? Or
so if
how do you identify if the target's not in the query list?
so how do you say? So if this is a laptop, but my query list is focused on animals. So when I found this, I think it's a laptop, it's an object, not animals. Then I use maybe a large language model to generate some potential query list.
New queries to put
Yeah.
in. What I think is that you need to, in your PhD thesis,
Yeah.
you will hopefully have 3 works, and you need to be able to tell some coherent story of why those 3 works fit together.
Yeah. Currently one is uncertainty estimation for flattened classification. Then I focus on hierarchy aware classification.
Yep, and that you use your first work as one of the methods in that, so that ties in.
Yeah.
Your third work, maybe if you're exploring the open set problem
Yeah.
and checking if you can use,
Hierarchy.
maybe if you used a hierarchical approach, like maybe, for example, let's say Malamute is not in there.
Yes.
Let's say Malamute's not in there,
So
and is a Malamute.
so
Just wait. Let's say it's an image of a Malamute,
yeah.
and it's not in the query list, so it's open set.
Yeah.
And when you're testing, you identify, okay, retreat to dog.
Yeah.
Maybe you could explore how can I then find what the missing label is, given that I know it's a dog and it's not one of the ones maybe in my query list. Maybe like that could be something you look at, but I think you need to really carefully like scope it with this previous work you've done. You need to make it like there's a clear story.
Yeah, so currently the I think if I do this, I think I need to design a new matrix, because currently for open set classification, if the classification result is if it is a Husky but the classification result is a Malamute, the series of error is the same with so it's not the series of the error. It means, so if the classification is a Malamute, or if the classification result is another it's a keyboard, so current matrix cannot measure there.
Yeah, if you're doing a slightly different task, you'll need maybe not new metrics, but you'll have to define the task well. That's right.
Yeah.
I'm just gonna check. Do you know if the others have clicked attending on the event?
I'm not sure.
I think they have.
Are they very busy recently? Are they Miriam and Will are very busy recently?
I don't know. I'm not sure. Maybe let's just start anyway. It's 5 past.
Okay.
I have to go on time today.
Okay. So I want to review my paper at first. It's so what I focus on is so vision language model based hierarchical selective classification. It's different with traditional hierarchical selective classification, because for vision language model we can leverage internal nodes. and this can explore the vision language model's hierarchical semantic structure, and then this make top-down traversal strategy possible.
Okay.
And the matrix is HAURC. It's the area under risk and coverage curve. The risk is 1 minus top 1 accuracy, and the coverage is the coverage is so when the prediction is leaf node it's 1, and when the prediction is root, it's no any information, it's 0. So now my research question I have 3 research questions. One is, does vision language model contain useful hierarchical semantic structure for hierarchical selective classification? The second one is, how do traversal strategy affect hierarchical selective classification's performance?
Completely forgot anything.
We're just recapping what the paper submission did.
Okay.
Did I continue
I
or
think you're good. I think Mariam remembers the beginning.
Yep.
parts, yeah.
okay? Now I have three research questions. The second one is, how do traversal strategy affect hierarchical selective classification's performance? And the last one is, should we split prediction and uncertainty when we do vision language model based hierarchical selective classification?
Yep.
Yeah. And the setting is, to say the unified prompt means a photo of an object, and hierarchy aware prompt, this leverage the hierarchical taxonomy. So like
I think we're
what's this 305 mean? It's a typo.
Maybe one thing, can you just explain how co-op works? Because I didn't really get time to read the learnable co-op paper prompt.
So this is a training so first it only use, so how to explain it, so so the clip backbone, the text backbone is frozen, but it's use its token is learnable. So it has if I have 3 in my setting I use 16 learnable token.
Okay.
16 learnable token, and then just this 16 learnable token are just 16 token are learnable, and
You're learning to maximize the learnable tokens get put in front of the original text prompt?
Yeah, for if the learnable, so when I initialize it, I have 6 learnable token. It's for example 16x, and I put this 16x in front of the object, so 16x and then dog.
Cool. And then you just train with the ImageNet images to maximize similarity between the image and its respective.
Yeah. It's same with the traditional training strategy, but yeah, I just use for example, if it's husky, I also train with husky, dog, animal.
Yeah. And is the learnable prompt the same for different hierarchy levels?
Yeah.
Okay.
And not only leaf nodes. Yeah.
Cool.
Yeah. So now my paper has some issues. So one is I think it's very important. So the experiments are not consistent. So at first, I found the learnable prompt is good, but when I explore research question 3, when I analyze whether we need to apply prediction and uncertainty, I still use unified prompt. I think I need to change it.
I think also, like, you know how we've got research question 2 and research question 3? So
Research que-
one is like the traversal strategy and one is the prediction and uncertainty method. There's probably some, I don't know if you can do them fully separately. Like maybe the best prediction strategy and the best uncertainty changes a bit depending on your traversal strategy.
Yeah, why I didn't mention it because bottom-up climbing strategy is still the best strategy. So here I still use bottom-up climbing.
I think that's okay, but I think, you know, like I like how you had the 3 research questions,
Yeah,
but I think you then tried to answer them progressively. So you answer research question 1, then you go to research question 2, then you go to research question 3.
yeah.
And I think research question 2 and 3 might be linked. Like to me, it makes sense that maybe the way you do what you used to do prediction and what you used to do uncertainty estimation might influence the performance of the traversal strategy. Do you know what I mean?
So what my understanding is, so when I found as research question 1, I found learnable prompt is the best.
Yeah.
Then in research question 2, I use learnable prompt and explore which traversal strategy is the best. Then I found bottom-up climbing is still the best strategy. So at research question 3, I use learnable prompt and bottom-up strategy too.
Do you understand what I'm saying? Not really?
Not.
What I'm saying is that, you know how when you did your experiments at different hierarchy levels, you
Yeah.
found different types of uncertainty worked better
Yeah.
at different levels.
Yes.
Remember? Yeah. So I guess if you are using a top-down traversal strategy,
Yeah.
maybe the best uncertainty for that top-down is different to the best uncertainty for bottom-up. So maybe you have to do the combinations of prediction, uncertainty, and traversal strategy rather than this like more stepwise for research question 2 and 3.
So you mean in research question 3, I still need to do top-down?
Like I think it could be something that maybe comes back to the reviewer. I just don't think the first question, it makes sense to me that you can totally separate it out.
Yeah.
But the other two, I think there's going to be interdependencies. And I think you had observed that sometimes where something that's best for one is not always the best for the other.
Oh, yeah. I get it.
So just something to, yeah.
Okay.
Can I see research questions again?
Okay. Yeah, here. So currently at the research question 2, I found so bottom-up climbing is still the best, but if I use probability density, softmax probability density, top-down can work, but not the best. Yeah, so at research question 3, I can use both top-down and top-down and bottom-up to test it.
I think I'm not trying to suggest necessarily like running any more experiments at this stage. It's just something that jumps out at me with those second 2 research questions. To me, they seem linked. They don't seem like things you can neatly disentangle from each other. I think there's some relationship between them.
Some relation, yeah.
Do you know? Yeah.
Yeah, I can guess this. They have some relationship.
Lynn, I think like, yeah, I'm just saying we need to keep this in mind. Yeah. Yeah.
Uh,
Don't worry, I'm not trying to say like do the extra experiments for it. It's more just I think when we go back and you like update the paper with the new stuff you've done,
yeah.
maybe rather than having these as separate sections,
Uh,
number 2 and 3, it might make sense to do like one big section where you answer both research
yes.
questions.
Yeah, you mean so I have two big research questions, but for the second research question, I have two sub questions. One is traversal strategy, and one is prediction and uncertainty issue. Do you mean this?
No, so I think you don't need to change the research questions, maybe just the structure of how you present them,
Oh,
the
okay.
results. Yeah.
Yeah, yeah. Do I need to continue?
No, yeah, that makes sense. So are we then sticking to one of, based on like what you say, it's best to stick to one of these traversal strategies and then
I think it might be better like
easy.
if there's a trend where certain types of uncertainties and certain types of predictions are better for different traversal strategies, I think that we should be able to say that as a conclusion. Like that would be an interesting conclusion, rather than necessarily just sticking to one.
Yeah.
Like maybe we say bottom up seems to perform the best,
Yeah.
but if you were going to do top down, the best prediction and uncertainty to use would be this.
Okay. Yeah.
Like I can think of certain applications where, you know, it might be desirable to do top down.
Yeah, I was about to say it probably depends a lot on the data set.
Yeah.
So
In
it's
some
not
data sets, it
like
might be better to
yeah,
do top
yeah.
down.
Yeah, I think yeah, for data set, I think INET and ImageNet has different results. Let me show this. I try three different backbones. Clip Clip Vision Transformer Large 14 and Clip Vision Transformer Base 16. This is the additional two, and this is ImageNet. It's same with provides result, but for INET we can see. I go back ImageNet. Okay. The learnable prompt is the red line. It's still the best UI.
And what's the unified prompts with aggregated? So learnable prompts, and go to the far right, please. Keep going to the right.
Okay.
Keep going to the right.
Okay.
So it looks like there's a bit of a different trend with like the different backbones, hey?
Yeah.
Okay.
I think the INET performance is it's still running. So we can say the learnable. I'm not sure whether this is because my learning rate or some hyperparameter settings problem. So according to my understanding, learning-based methods should be a way better than uniform prompt and hierarchy aware prompt. But let's see the Siglip performance. So when coverage is 1 means it's the leaf nodes performance. Its accuracy is recent, so
Are you using the Siglip loss or clip loss?
I use clip. I don't use for Siglip. I don't use Siglip papers loss function. I use sim loss function. I think they can be compared fairly.
What?
So I just use normal cross entropy loss.
That might be a problem. I guess the whole point of Siglit, right, was that they said it's better to do binary cross entropy
Uh,
and sigmoid activation and not use clip. It's like
so you mean if I use Siglip, I should use Siglip's loss function, but not sim loss function.
yeah, not clips.
Okay.
That would be my gut feeling on why
Yeah.
it's like much worse on Siglit. And you know how before you noticed like Siglit doesn't even in the ImageNet Siglit
Yeah.
is not as helped by the learnable prompts as Clip. That might come down to something to do with like the big difference in how the backbones are optimized. I think they can behave quite differently because they're trained quite differently.
Oh yeah.
But
I think I would stick with would you do the same? You'd stick with the
yeah, I don't
Siglip
I
Plus?
didn't know that Siglip Plus. I don't know.
I think Siglip is basically like almost the same as Clip, but it does
The loss function is different.
instead of softmax, it does sigmoid, and it does binary cross entropy instead of cross entropy. So it doesn't enforce this harsh one or the other when it's training.
But then like even if it's the wrong loss, do we expect generally with clip loss to, for example, learnable one, because it's trained for that loss, right?
Yeah.
Like I mean relatively. Again, I understand that this is not the right thing.
Maybe it can't learn.
Yeah.
I mean, it does seem weird that it's worse. Does
But-
the accuracy? No, the accuracy is worse at
Yeah.
the leaf node.
Yes.
That's very weird.
Yeah. Maybe I need to change the loss of.
You're not using the scientific names, are you?
Yeah, scientific. I use the scientific name. So, why I use it? Because if I use common name, so the performance doesn't improve too much. And for some internal node, they don't have common name, and some common names are same. So I still use scientific name.
But I just about that question, I think in like we are like why you think we should be using clip loss? I think like for each of these, what you are proposing to do analysis doesn't relate to that loss, is something else. So maybe it makes more sense to stick to whatever the whole thing, like Siglip, is doing, just to add your components to that structure. Like it's just there are prompts and things like that that you want to learn or unify stuff for other experiments. But yeah, these things could be highly optimized for the specific design for all.
Can you go back to ImageNet? Yeah. Yeah, see how it's Siglit.
Yeah.
See how the accuracy at the leaf node is better? The risk is lower?
Yeah, the risk is lower.
That's what I'd expect. In your Siglit, you've actually. But first of all, I would retry this, but use the Siglit loss
Yeah.
for ImageNet because that's well behaved. With INAT, I find it very weird that your
I think
accuracy gets worse.
Yeah, this is a great issue, I think. So after training, the performance is worse.
Which might be overfitting.
I don't
Yeah.
think over.
What's the train test set like in INAT? Are they very different? Like you still have the same.
I use the same. The batch size is different, but
No, like kind of if something is trained on train, it's supposed to do well on test. Is their test set very like kind of difficult or different?
I'm not sure. I don't think I.
You
So
have
how-
done like kind of other experiments on INAT before, right? In your first paper? No?
No. In my first, I don't
You
use
didn't do it.
INET. Yeah.
I remember INAT like for another work, it has 13 coarse categories
Uh,
and a lot of fine categories. INAT 2017. Which
uh,
INAT you're using?
INET 2021, I remember. I remember the INET
So you're
2021.
using super classes? They always call these super
Yeah.
classes. So it's only 13 classes around that.
Third,
That shouldn't be very difficult then, if you're using those super classes.
not 13, 100.
So
No, not 100. 10,000 classes.
okay, so then
10,000 classes.
okay, so you're going to the fine version. That could be very complicated, you know.
Yeah.
Um,
For training data, so each category only has 50 images. Is that an issue?
Yeah, like under the main issue is to see if it's really overfitting or like
something's going wrong there.
Yeah.
I think you need to look into it. Did you use iNaturalist through Torch Vision?
Which vision?
Did you use the dataset through Torch Vision? Torch Vision.
Yeah.
Is this, so you're doing the experiment in the same way that the hierarchical selective classification paper did it? Is try and follow. Yeah, okay. So in hierarchical selective classification, evaluations were performed on the INAT 21 mini dataset.
Yeah.
50 examples each for 10,000 biological species in a 7-level taxonomy.
Yes.
So they're using the Torch Vision version. So maybe just for completeness, you should also use the Torch, Torch Vision.
Yeah, I know it, but I think it's same with Touch Vision.
And you're using the INAT 21 mini?
Yes.
Okay. Yeah, okay. So I guess, Lynn, you have to, figure out why something looks wrong with the INAT numbers with the learnable prompt.
Yeah.
And have you checked if the number that you're getting with the aggregated, does that match the number in the hierarchical selective classification paper?
I've not. I think I need to do this.
Just started to check.
I'm not sure whether the. Yeah, I remember they do not propose the INET, but yeah, maybe I need to check it at first. Yeah.
Yeah, they do their test on INAT, yeah.
Also just pull out your training epochs, the losses for your on the train and test it. Let's see if they are really decreasing its training or not.
Yeah, I need to check the root
Simple
curve.
things that you do with just making sure that your network, that prompts are properly trained or not. Okay.
Okay, yeah.
Let's do it.
Yeah, let me.
If you want to show that like, and the different traversals have or might need different, like an uncertainty and prediction, like kind of, like, I'd say approaches, then what data sets, like, are inherently we know that they might be different. Like with ImageNet INAT, I think it's probably almost the same, right?
Probably. I don't know. I think it would be, there's not that many data, like big publicly available data sets, but maybe the other way to flip it a bit is like this one, for example, like see how at the low end of risk, unified prompts comes out as the best, but at the high end of coverage, then it's worse. That might be something where we say, like, look, if you really care about having no error, then top-down traversal is better. Like if you want to operate at very high precision, then it might be better to use top-down. If you want very high coverage, then it might be better to do bottom-up. Like I kind of wonder, like, when you're looking at this like HAURC metric, that we probably also want to show the curve
Yeah,
of
yeah.
different traversal strategies.
Yeah.
Like that might play a role. Is my feeling. Yeah. Like if I've got an application where I want basically no error, where I can only have like 5% error,
Yeah.
then I just want to maximize my coverage. It'll be different for different methods.
Does that make sense?
Yeah, so maybe different strategy. So if we want a low error, but I don't want a very specific classification result, very fine-tuned, not very fine-grained objects. So maybe use top-down. So
maybe, yeah.
yeah,
Depending on the curve. Look, I guess if I said to you, I only want an error of maximum 5%, like which method should I use here? So I want my risk to be 5% or less.
Yeah.
Which method?
So if we want a very low risk, so the learnable prompt when the coverage is very low is the best.
Yeah, but then if I said I'm okay to have a risk of up to 50%, you would change, right?
Yeah.
Yeah. So I suspect it'll be the same as like the top down versus bottom up.
Yeah.
Which is, I guess, the whole like advantage of this whole method is that someone in different applications could tune how much coverage they're willing to sacrifice for different levels of risk.
Okay. Yeah.
Do you have other results you want to show us? Is that the main ones?
Yeah. This is the question 2, the different traversal strategies performance. So what I want to say is the top down, but not top down. Bottom up is still the best. So top down descending with max pooling can work, but not the best. It's similar with bottom up climbing.
So I think you need to do the plots, right?
Yeah.
And for example, like, I wonder what would happen if you had the prediction with the learnable prompts, but uncertainty with PDF.
This PDF do not use learnable prompt. It's same as do not use.
But what would happen if you did prediction with learnable prompts and uncertainty with PDF?
prediction, it's in this. So another question is, so if so previously you said I use a table is not very clear, but I'm not sure how to show it with a figure or. So if I use this is bottom-up claim. Bottom-up claim is the result. If I use cosine as prediction and PDF as use PDF as a setting is always better. But if I use, I think prediction and uncertainty should be different.
I think we should change the research questions. One should be, how do you best do prediction for internal leaf nodes, like to leverage understanding inside CLIP. And then you can do prediction with cosine, comparing actually like testing it versus aggregated. You can do prediction with PDF if you want.
Yeah.
And you can do prediction with the learnable prompts. And I think you actually are missing a baseline where you would do learnable prompts for the leaf level and then aggregate.
Yeah. This cosine means it's a learnable prompts cosine similarity.
Okay, and then you need one that's just maybe. I kind of think maybe if we talk about prediction first, and then it's. Then maybe you look at uncertainty and traversal. I know you've got a lot of like results and have to figure out how to nicely show them, but I can tell you a table is not the answer. You might have to be creative and look into different ways to like present results.
So table is not very clear to show the answer, you think?
Do you think it's clear?
So I
Let me flip that back to you.
So I think because in this table I want to show both ImageNet and INet and different combination of prediction and uncertainty. So I want to show lots of information in this module.
So have a look at the results and tell me what the takeaway is.
So if I use a bar plot, I think if I use a bar plot, what I think I can only show maybe ImageNet and with if a prediction is cosine and a different uncertainty.
I think this is something you're going to have to figure out. I don't think we can. This is something you're going to have to play around with probably, and look for inspiration online and try different options, and start using some of your judgment for. I don't think I can give you the answer here.
Oh, okay.
This is your job to start figuring out.
Okay.
Yeah. I can just tell you now, if I was a reviewer and you wanted me to look at this table and try and understand it, I would not be happy.
Okay.
Because it's like I can't. It's just numbers.
Yeah.
There's like not clear.
Yeah, not too many.
Way too many. I can't. If you're trying to say there's a trend, I can't tell what the trend is.
Yeah, because I think if we fix the prediction as a cosine, and then if I use different uncertainty, if each uncertainty is independent, so I can't say it has a trend or.
Okay, so
anything.
maybe the logical thing is to disentangle it, where you say the role of the prediction mechanism is to maximize the accuracy, and the role of the uncertainty mechanism is to maximize when you move. So maybe you find the best prediction by looking at how well different ones classify at different levels in the hierarchy, and then you use your HAURC when you're looking at different uncertainty mechanisms. And so maybe you can do something where you just do prediction first, you have to do your own. It won't be HAURC. It might be something like the accuracy at different levels in the tree. You pick whatever's the best from that, which hopefully is like the learnable prompts as you found, and then you ablate over uncertainty types and traversal strategies. And then you've only got 2 dimensions that you're ablating over instead of 3.
Okay.
If you don't consider backbones and data sets.
Yeah.
To 4. But that to me is like logical that it might make sense to disentangle those things. But yeah, you'll have to look and think about it
Okay.
and come up with a plan.
Okay, I get it. Okay.
Yeah.
Yeah, this is the effect of sample size. For INET, the INET result is still running now.
Can you go back for a sec?
Yeah.
Oh yeah.
Yeah,
Maybe
for Gaussian and PDF, I use PDF as uncertainty, but use cosine as leaf nodes prediction result.
And so, okay, this is something where maybe again you would disentangle prediction and uncertainty. So I think maybe I'd want to see this also for like accuracy
Oh,
if it was me. Because linear probe is really to do with the prediction. Softmax of PDF is really to do with the uncertainty. Learnable prompts really to do with prediction.
but prediction is each level's prediction, or leaf nodes prediction, you mean?
You could do either. Maybe both.
Okay.
And I think you'd want to have a star in here or a dashed line that shows the best method that doesn't need any data, that's data free.
Okay. Yeah, just a zero shot baseline.
Yeah. Yeah, with softmax scores uncertainty or something like that, or aggregated softmax.
So just softmax cosine. Yeah.
Just so you know, at what point does it, like maybe learnable maybe at 5 samples, it's actually better just to do 0 shot. I don't know. Okay. Cool.
Yeah. That's all today, and yeah.
So, maybe if you do the other experiments we talked about.
Yeah.
But don't change the paper, and then we use the rebuttal round just to change the paper. But I think your instinct was like adding more backbones and another data set is the main.
It's the main thing.
The main priority.
Yeah.
But please just sanity check the performance you're getting on Naturalist matches what's in that previous paper.
Yeah. I need to check it.
Do you want to ask Mariam about what she thinks about your next project?
Yeah. So currently, after I discuss, I think the next project maybe could be on OpenSet. So previously, the first project is a flatten classification and uncertainty on flatten classification. And then here I consider hierarchy-aware classification. And maybe the third project could be if the when if the for example it's a husky, but it's a husky, but if the husky is not in the query list,
Mm-hmm.
then the if the prediction is Malamute, it should be better than than other irrelevant predictions such as keyboard, mouse, and maybe yeah.
Yeah. Makes a lot of sense. I think it was been like we've been kind of thinking about that for a while, but we never got into the stage because we are still like working on the like non-open set works. But yeah, that's quite interesting. And that like should work, but we'll see.
Do you have any other suggestion?
No, it's just so like you want to like basically try open set on what you have, right? Or what do you think, like what else we need to have there? Because currently you're doing this per level, right? Prediction still is per level optimized in your hierarchy. So then how, if you like kind of have something like this, you always go with like how you should like kind of optimize this within levels if it's an open like kind of a new class. You will start with the kind of leaf classes and then go up.
You mean how?
So our open set is like at the level of leaves, right? Are like kind of always new
I guess it could, to be honest, it could be,
everywhere.
yeah, like potentially it could be something that we don't even have the next level up for.
Yeah, so it just
Could
kind
be at anywhere in the
Mm.
hierarchy all the way up to the top, I guess. Well, I guess I don't know. That's what we'd have to decide. But from like an application perspective, yeah, it probably could be anywhere, but less likely the higher up you go. But I think Lynn was saying you're interested, right, in more how you adapt if you know something's open set, right?
Yeah, but so currently, what I want to do is if it's husky, but husky not in the current list, I want it to go back to dog.
And then what you want to do after that?
So if it's a dog, I think it should be it's good. But if I think it's if the class if the prediction is Malamute, it's sure how do you say? I don't hope, even though it's very close. I hope I don't hope it is class it will be classified as a wrong label, it's a wrong target. I want to, it's yeah. Do you understand it?
No, I think I'm confused. You might have to try.
Yeah. So now I have two targets. In my credits, I have husky and Malamute.
Yeah.
Then my input image is a husky. So currently so because I have two husky is in the query list, so the prediction should be husky. But in OpenSet, husky is not in the query list.
Yep.
So what so if I use traditional zero-shot classification, it should be classified as Malamute because it's the most similar.
No. Oh, you mean what do you when you say it should be? Do you mean it
So
might be?
yeah, might be.
Okay.
Yeah,
Yeah. So it might be yeah.
yeah,
But you would want the system to be able to say, I'm not sure it is a Malamute though, and retreat to dog.
yeah, yeah. But but uh, but it is a misclassification. I hope because it's a husky. I hope it's need to go up and go to the high level and it's a dog,
Yeah.
but not a Malamute, even though they are very similar.
Yeah.
Yeah, this is what I hope to do.
And then like for this, how you are like because you're using clip, right? Still, for example.
Yeah.
And then probably all of these classes have been seen. So how we have open set really in that scenario?
So if you give a query list that doesn't have the text prompt for Husky in it.
Oh, okay.
But I thought you were also talking about like if you do retreat to dog, then what can you do to like expand more potential labels into that?
Yeah. But I think it needs a large language model's help.
Yeah, you could do that.
Uh, uh, so if I found it's a dog, but husky, so for large language model thing, it's a dog. So how do you say it? So large language model should propose some potential labels.
That's what you were talking to me about before.
Yeah.
Yeah. I guess so. So if I think if you're like thinking about the next chapter, just a system that does this but an open set
Yeah.
is not that big a extension of this work. It's not really, you know, it would be very trivial for you to like just adapt this to the open set and check, you know, then the best label it can do. So coverage of one would be the dog. I think that would be fine for you to do. But if you're more proposing this like system where it is open set, it then knows how to respond and potentially find the correct label, and you do it using a hierarchical framework, that's like probably a bigger contribution. And you could do all sorts of things, like you could use a large language model where you could say, what are other types of dogs? You could say, given that the model says it's most similar to a Malamute, what are potential other similar classes I might want to add to my list? You know, there's a few things you could do. But I think there are papers that adapt their query list based on large language model stuff. So you'd have to look into the literature for that.
Yeah, so if the label is not in the query list, and use additional large language model to propose some labels to address open set problem.
That might be, but what I would really like, rather than thinking of the solution,
Yeah.
try and think of like the research question that the final work you're doing will answer,
Yeah.
which might be how can a vision language model adapt when it is in open set?
Yeah, okay.
So even if you have a language, so it's just like making your kind of prediction, backing it up with more evidence, right? That's what you want to do with that language model, because even that language model could be some like kind of not that certain, right?
Yeah.
So like you can just definitely consider that as something to add more, but then what's like even in that one, even if you have something uncertain, for example, at leave notes, it's something has been rare that none of these language models have seen much, or like kind of they cannot distinguish properly. So then what's the solution given this hierarchy? I think like what I'm thinking is suppose you need to have an optimization, like tree-level optimization.
Tree level.
Like not just like going one up and what's the like most suitable one, or if I should go this or like somewhere else, you just like get like kind of an optimization from if I start from this leaf and go up. So it's just your traversal altogether optimization problem. So this gives me like kind of, for example, this value is just this risk if I choose this one based on the whole path. If I just start with another one and then based on these three, I'll end up somewhere else, which could go very wrong. Then based on that, I'm just thinking if it's open set might be more like kind of having really something, using the whole like kind of path in the tree for that specific should be like kind of more evidence, gives more evidence than just one level up, right?
Yeah. So gradually go up, then find some
You already
possible.
have this travel, so with like kind of a path for your tree.
Yeah.
So now if you're just saying that if this one is uncertain, you'll go to the top one.
Yeah.
And if that's like kind of, if you have like more than one level, then what happens? If like you have multiple options, and because you have so many classes, it's very possible that
Yeah.
you have like kind of at least some candidates
Yeah.
to start with. Then like the next level, do we really expect that like if we go one level up suddenly, like kind of one of them is way like kind of the probability of one of these like parent ones is way higher than the other one?
Currently not currently if I use your if I do not use aggregated softmax probability, it's not absolutely higher than leaf nodes. Not absolutely.
Okay, yeah, probably we'll need to think more. I definitely start with the simplest thing first to see if we get anything or not.
Yeah.
It could also show you some of like how you found that really hierarchy in Clip doesn't like kind of perform as we expect and things like that. You might find some other things when starting with this simple.
I also think your final seminar is due in a year, I
Yeah.
guess now, which for your final seminar, you need to have a full draft of your thesis. And I think it's probably going to take you, at least 6 weeks to put together a full draft of your thesis.
Yeah.
So for this next paper, you're going to have to move a little bit quicker. So
Yeah.
I would kind of try to scope it so that it's not too
Exploration.
ambitious or exploration focused. I would try and scope it so it's something you're confident that maybe you can get done by March next year, April maybe.
So your seminar is on March?
No, the final seminar's in June.
July.
Yeah, some mid-July or something.
Yeah, mid-July.
So mid-June, mid-May. Yeah, kind of, I think around mid-May you should be starting to write your thesis. So yeah, we'll need to be very careful with this next one.
Yeah. So I think now I need to do some literature review and I think about the research question at first. As the first step is important.
I think focus on getting the rest of the experiments for the WACPI paper, and then yes, start doing some literature review so that you know what the gaps are.
Yeah.
And we don't start doing something someone else has already done.
Yes.
Yeah.
Because I can also see, like, no one's really doing the stuff in object detection. So that would be
Very not like
a very natural extension that feasibly should be possible, and no one else is doing it, so there's no competitors. You know, so you could just do hierarchical in object detection. But, you know, I think you need to think about it and write a plan.
Okay. Yeah.
before starting any training or whatever, just the assumptions that you have about how this is supposed to be working, just like play around, like kind of try different, like place one of your data set with some of the samples and see what you're thinking now that like kind of is really happening or not. Because like your assumption might not hold,
Yeah.
right? And
Yeah.
then whatever you design then doesn't matter.
Okay.
So let's see. But then before like kind of really starting lots of experiments, make sure that what you think or just the logic you have is actually
Yeah.
what we see that works.
Thanks,
Okay,
Lynn.
good. Okay, thank you very much. Yeah, see you.